Hi, it's Denise De Los Santos. This week's interactive lab presentation is going to be presented on the fireproof balloon. This week, in this week's lab's description, we learned that gases are less conductive and that causes heat to transfer at a much slower rate. Usually when we put our hand near heat, such as fire, so this is fire, and we put our hand over it, our natural reaction is to move rapidly from the fire. So we'll move our hand from the heat source fairly quickly, and we learn that at a very young age. And that is not only because of the lovely sensors that we have on our hand, but it's also due to the fact that heat transfers fast and quickly, and that's one of the examples I could think of on the top of my head. So in gases, this is the complete opposite. It does transfer at a much slower rate. This week's supplies, we're going to go ahead and utilize our heat source, which is going to be this lovely lighter right here. We're going to have use some water, balloons. So one balloon is just going to be filled with air. So I went ahead and blew in some air into this balloon. So this has nothing in it except for my air that I blew in there myself. And then this lovely balloon right here, this, as you can see, this pink balloon has some water right here, water at the bottom. Can you see? And obviously some air on top. So we can see some water and some air inside this balloon. So we have two different balloons right there, one with air and one filled with water and air. And then this bucket in case there's a mess right under the experiment. So we're going to go ahead and see what happens to each balloon as we apply this heat to both balloons. So this will be applied to both the air balloon and then the balloon that's filled with air and water as well. So I'm going to go ahead and take each balloon and we're going to go ahead and discuss what takes place. So the first balloon, kind of have an idea what's going to take place here once we apply the heat source, but let's see if this happens and takes place. So we have our heat source right here. We're going to turn our heat source on and we're going to go ahead and apply the heat to the heat source, to the balloon fairly quickly. We're going to be able to see what takes place. So putting it to the heat. Oh, there it goes. It pops. So that's what happened to the first balloon. And that balloon, again, was just filled with air. And the reason a balloon filled with air pops is because when you put it over the flame, it's because the rubber on the balloon is very thin. So the heat transfers fairly quickly through that thin material that the barrier that balloon has, which is very thin. The heat transferred so quickly through it. And keep in mind that thin barrier is very weak and it could break very quickly because that heat is transferring so quickly through it. So that's what happened. That's what took place with the first balloon. So I wasn't really too surprised with that. But with this other balloon right here, hopefully this doesn't happen to this balloon. Because that's why I have the bucket at the bottom just in case. Okay, so we're going to get this balloon now. Which this is the balloon that has the water and a little bit of air on top, just as described. So we're going to go ahead and get our heat source once again, right here, and we're going to go ahead and turn this on. Sorry, I struggle with the safety sometimes. And we're going to go ahead and apply that heat source on the balloon just to see what takes place here. So heat source on the same. Oh, we can see the flicker. That's interesting. Go ahead and do it again. Sorry, I'm struggling with my lighter. Put the balloon down real quick. I think it's because my hand's pretty small. And this is pretty big. Okay, and once again, we're going to go ahead and apply the heat again to okay, that's very interesting. I don't know if you can see, but as I was applying the heat source for a good amount of time, there's been creation of soot. at the bottom. So this balloon did not pop. So I'm kind of able to, oh, you can see it right there. I'm able to kind of rub this off with my finger, and it created a soot. So in the second balloon, this pink one that was filled with water and the extra space filled up by air, the water-filled balloon, the reason why it does not burst is because the rubber does not reach a temperature sufficient for it to melt. The rubber is stretched so thin that the heat is quickly transferred into the balloon, just as the first balloon. How we saw that heat just transferred through the first balloon so quick that it just popped so quickly. Yes, that's the same here. The rubber is stretched thin so that the heat transfers quickly through the balloon. But with air inside the balloon, this heat is not readily dissipated away from the spot touching the flame. So that spot I was touching, that one spot you could see kind of in this area right here that I was touching, this area, the heat is not readily dissipated away from the spot touching the flame. As a result, the balloon partially melts or burns. So it did partially melt, and that's why we kind of see just a little bit. Water, on the other hand, has an amazing capacity to absorb heat. This heat is readily transferred into the water inside the balloon and away from the wall of the balloon, so the rubber does not heat up enough to burn or melt the balloon, actually keeping it from bursting. And that's exactly why it did not burst, because the water heat capacity is so much higher, and has a higher heat capacity and could withstand that heat transfer. So that's exactly why that did not burst. Thanks so much for watching. I'm glad that did not burst on me. It would have been a bad cleanup. Thank you so much, Professor.